Have you ever wondered what happens to your favorite photo or your save file in a video game when you turn your computer completely off? Where does it go when the screen goes black? Looking at this illustration, on the left we have a powered-down monitor, but on the right we have the answer, a safe, permanent lockbox. We call this a storage device. It's the place where a computer securely keeps your information when the power is off. Sometimes this lockbox is built right into the machine. We call that internal storage. It's permanently housed inside your computer, laptop, or tablet. But as you can see in this X-ray view, you don't always have to keep the box inside. On the right, a USB drive plugs in from the outside. That is external storage. It acts like a removable backpack that you can detach and carry with you. Whether it's built in or plugged in, computers absolutely need these physical spaces. Without them, our digital lives would vanish the second we flipped the power switch. So, how exactly are these digital lockboxes built? Computer manufacturers rely on three completely different physical methods to save your files. The first method is shown in this diagram of a hard disk drive. This is magnetic storage. It uses tiny magnets on that mechanical arm to write information by sweeping across a rapidly spinning disk. The second method swaps magnets for light. Watch as the disk here transitions into a shiny DVD. This is optical storage. A glowing laser beam strikes the surface, burning microscopic pits and bumps into the disk as it rotates. The third method gets rid of moving parts entirely. Here, the disk fades away, replaced by a solid-state circuit board. Drives like this use pulses of electricity zipping through silent microchips to save data. Magnets, light, or electricity. They use entirely different laws of physics, but all three technologies are designed to do the exact same job: securely lock away your data. This brings up an interesting question. What exactly are those magnets, lasers, and electrical circuits writing down inside the machine? They are writing in a secret language called binary. As you can see in this stylized word, computers don't understand English or Spanish. They only understand this specific code. The strictest rule of binary is right there in the name. Bi means 2. The entire language consists of only two numbers, 0 and 1. Think of those zeros and ones like the heavy metallic toggle switch in this video. When the switch is snapping into the on position, the computer reads that as a 1. When it flips off, the computer reads it as a 0. Every photograph, every text document, and every video game you own is ultimately just millions of these microscopic on and off switches, hidden deep inside your storage hardware. Let's give a name to those individual switches. A single 0 or a single 1 is called a bit. It is the absolute smallest piece of data a computer can hold. 1 bit on its own is too small to do much. So as this diagram shows, we group them. Watch these 8 individual blocks sliding together to form a single bar. That group of exactly 8 bits is called a byte. As our files get bigger, we need larger units of measurement. If we zoom out here, you can see a storage ladder. Bits and bytes are at the bottom, but we have to climb higher for real-world files. Taking the next step up the ladder requires simple math. Watch how 1,000 of those byte bars rain down and pack perfectly into a larger crate. That crate is called a kilobyte, or KB. The pattern repeats for the final step. 1,000 of those kilobyte crates compress together to form the massive, glowing container at the top, a megabyte, or MB. When you hear people talk about file sizes, they are just moving up this ladder to describe massive clusters of tiny binary switches. Now that you know how the ladder works, let's test your understanding with a math puzzle. Here is the first equation. If we have 4 bytes, how many bits are hiding inside? Since every byte holds exactly 8 bits, we multiply 4 by 8. The answer is 32 individual bits. Let's try jumping up the ladder. Look at these 3 massive megabyte containers. How many kilobytes make up 3 megabytes? Since every megabyte is 1,000 kilobytes, we multiply 3 by 1,000, giving us 3,000 KB. This brings our entire journey together, right here on this summary screen. On the left, we see the physical boxes, magnets, lasers, and microchips. On the right, the math, bits scaling up to bytes, kilobytes, and megabytes.
Understanding digital storage means realizing that the heavy physical hardware sitting on your desk is perfectly designed to protect the fragile, invisible math that makes up our digital world.